All right, so for number 2, it says, what is the degree, the zeros, the multiplicity, the end behavior at the x-axis, and the end behavior of the polynomial function as a limit. So these are things that we done before in class, and you're responsible for knowing all of these concepts. So let's begin. Actually, I want to target, let's target your degrees and the end behavior of the polynomial first. Then we'll target the zeros, the multiplicities, and the behavior at the x-axis. So, to find your degree and the end behavior, we need to know the leading term of the function. The leading term of the function. So, let's first find the leading term, which is LT. To find the leading term of the function, you're going to find the product of all of the leading terms of the function. So that means we're going to multiply our 2x cubed, which is on the outside. Just put that in yellow. With the leading term of the second factor, which is x. But this is x squared. So we're going to multiply that with x squared. And then we're going to multiply that with x squared once again. And when we multiply 2x cubed with x squared, that's 2x to the 7th. So our degree, which is the highest exponent that our polynomial will be, is going to be 7. Now we can find the end behavior. When it comes to graphs based on its degree, we should know how a function looks like, right? So in this case, we can look at our degree, if it's odd or even. So degree, parity, which means either it's odd or even, and the sign of the leading term. If it's negative or positive. In this case, our degree is 7. So 7 is odd, and our leading term is positive. So that means, based on function shapes, the ends of the function looks something like this. Right side up, left side down. Put that in 2 different colors, actually. The right side of the function is up. The left side of the function is down. So if we focus on the left side, the limit of the function as x approaches negative infinity, well, if the left side is going down, the function is going towards negative infinity. Now look at the right side as the limit of our function as x approaches positive infinity. So that means as x gets larger in the positive direction, as we move more towards the right, the function is going up. So that means that function approaches positive infinity. So there you go. And this is your end behavior as a limit. You must be able to determine the shape of a function based on its end behavior, especially because this will be on the non-calculated part of your section. of your midterm, as well as your final. All right, we found the degree, we found the end behavior. Let's move on to zeros, multiplicity. Spelled multiplicity wrong. Zeros, multiplicity, and behavior at x-axis. So let's take our function. We're going to take our function, which is m of x equals to 2x cubed times x minus 4 squared times x plus 6 squared. And to find the zeros, you're going to take your function equal to 0, and you want to solve for x. You want to solve for x. Here, we can use the zero product property, right? So that means we can set each piece equal to 0. 2 equals to 0. X cubed equals to 0. X minus 4 squared equals to 0. X plus 6 cubed equals to 0. And we can solve for x. First and foremost, we know that 2 cannot be equal to 0. Those are two different quantities. But for the next part, if x cubed is equal to 0, then by default, that means that x is equal to 0. And then if we have x minus 4 squared equal to 0, what does that indicate? That just also means that x minus 4 equals to 0. And if you add 4 to both sides, x equals to 4. That is a 0. And if x plus 6 squared, not cubed, equals to 0, that just means that x plus 6 equals to 0. Subtract 6 on both sides, x equals to negative 6. So we have our zeros. Our zeros is we have a 0, a 0, a 0 at 4, and a 0 at negative 6. When it comes to now the multiplicity is the number of times each factor occurs for the 0. For the 0, that is 0. We have x equals 0. But if you notice, this x equals 0 originally came from x cubed equal to 0. So that means its multiplicity is 3. But then when it comes to the other two, x minus 4 squared and x plus 6 squared, look at the multiplicities. Look at the exponents on each factors. For the 0 of 4, that comes from the factor of x minus 4 squared. That has a multiplicity of 2, as well as the x plus 6 squared, which gave us the 0 of negative 6. There's a multiplicity of 2 as well. Now go back to the shapes of a graph. A cubic function looks something like this. If you had an x cubed function, let me draw a quick sketch of it. It looks something like this. So if you notice, it crosses the x-axis. But if you have some sort of squared function or some sort of even power function, which I'm going to draw it up here. For example, we graph x squared. If you notice, it touches the x-axis. It curves and touches the x-axis. So we can use that to our advantage for our multiplicity. Because the multiplicity is 3, we know that the graph is going to cross the x-axis at x equals 0. But because the other multiplicities are 2, which are even multiplicity, is going to touch the x-axis. So touch the x-axis at x equals to 4. And it's going to touch the x-axis at x equals to -6. So even multiplicity is going to touch. Odd multiplicity is going to cross. And I said odd crosses. All right, guys, that is it to this video. Once again, we went over these concepts already. Please review your notes. And I'll catch you in the next one. Peace.